Hey there, I'm Roshni Sangvi, Product Manager at Couchbase. I take care of containerized and Kubernetes deployment of Couchbase Server, along with the third-party cloud-native integrations of Couchbase Autonomous Operator. I have 7 to 8 years of experience working in cloud storage and virtualization domain. I have worked on developing cloud-native orchestration workflows, automating file system cluster lifecycle, smart TV solutions based on latest technologies such as Docker, Kubernetes, and platforms, VMware, AWS, and GCP. I welcome you all to this session, which I'm co-presenting with Ron. Hey, Ron, please introduce yourself.
Thanks, Roshani. My name is Ron Graham. I'm a solutions engineer at Couchbase, and I've been here for a little bit, about 6 months. And what I'll be doing is doing the demo for you, so the easy part of the presentation. And I work closely with customers to configure and install and deploy Couchbase and Kubernetes and other types of platforms.
So this is the agenda for our session. In the first part, I'm primarily going to talk about why you should opt for CAO and what are the advanced capabilities of CAO. Then in the second part, Ron will demo easiest and automated ways to deploy Couchbase cluster using Helm and Couchbase Service Broker, followed by a demo of some key features such as cross data center replication and monitoring and alerting with Prometheus and Grafana. So first thing first, why CAO? In answer to this, consider the use case of cluster provisioning. To provision a cluster manually, you would perform all these steps. But what about manual approach to cluster upgrade, backup, restore, monitoring, high availability? It's going to consume a lot of time. We'll have a lot of maintenance overhead, operational cost, and it will be more error prone. So what's the best possible solution to this? It is automation. CAO provides higher level of automation across the cluster lifecycle. CAO is the best, most efficient Kubernetes operator in the industry. It's the most mature Kubernetes operator, certified at CMM level 5, which provides a true cloud-native experience. CAO is adopted by almost 200 enterprise customers who run Couchbase on Kubernetes in multi-cloud or hybrid cloud environments. It reduces their operational costs up to 95%. These are the cloud-native integrations that we provide today with Couchbase Autonomous Operator, CAO. These are highly adopted projects under the Cloud Native Computing Foundation, a nonprofit organization for Kubernetes. This diagram represents cloud native architecture of CAO. We provide various necessary integrations at each level, such as storage level. We provide GlusterFS, Ceph, Portworx to manage or automate the storage APIs or storage workloads. At cluster level, we have Prometheus and Grafana for monitoring and alerts. For package management and deployment, we provide Helm as well as service broker integrations. For log forwarding, Fluentbit, and for security, microservices, and Kubernetes native networking, we provide Istio Service Mesh, Core DNS, and CNI, which is Container Network Interfacing. Apart from standard capabilities of Kubernetes application, CAO provides many advanced features and capabilities, which no other Kubernetes operator in the database industry provides today. Some of those key capabilities are listed here. CAO provides automated installation, validation, authentication, maintenance, and recovery of Couchbase cluster with the help of dynamic admission controller, role-based access controller, and custom resource definition. You will have a highly available and fault-tolerant cluster at any point in time with node affinity. With CAO, you can do automated upgrade of Couchbase cluster, CAO, as well as the underlying Kubernetes cluster. Moreover, the Couchbase Autonomous Operator provides automated parallel upgrades. We call it one-shot upgrade, along with the option of traditional sequential upgrades. Most important is you can also do partial upgrade. For example, if you want to upgrade only 50% of your pods in the cluster, then you can achieve that with CAO. This feature helps you ensure zero downtime and consistent behavior with zero impact on performance during the upgrades. CAO also provides automated backup and restore to and from AWS S3, as well as some filtering capabilities with backup and restore. For example, you can exclude or include the particular bucket or services that needs to be backed up or restored. With latest Kubernetes versions, such as Kubernetes 1.18 onwards, we also provide online expansion of persistent storage. What is online expansion? Online expansion is basically without having to restart your pods, you can increase your storage, you can upgrade or resize your persistent storage. And that is applicable to both the backup storage as well as the regular data storage. And this helps customers to save cost initially, that is allocate the minimum storage to your cluster initially, and then increase the storage as per the requirement. Apart from these capabilities, we also provide a lot of security management that includes RBAC, LDAP, and TLS 1.2 support, along with the secret shadowing and support for PKCS HAT-ASH formatted keys. There are other key capabilities such as cluster hibernation and auto scaling, which are very, very important for developers, platform engineers to save cost for their testing and development efforts on public cloud. They can create their cluster and run the cluster whenever required, and they can shut down the cluster with the same configuration saved, and then they can resume the cluster later on, maintaining the state of the cluster. One more important feature is self-certification tool. It is very important for DevOps because you can self-certify a CAO with a particular platform you're running on. And this saves a lot of time for the DevOps engineers or platform engineers to, check whether the CAO is working with their platform or compatible or not. So we have provided this automated tool along with CAO. Apart from this, there are, as I mentioned earlier, there are so many cloud native integrations that we provide, such as deployment and package validation. We provide Helm and OSB API for monitoring, Prometheus, and log forwarding with Fluentbit, etc. Ron is going to talk about the cloud native capabilities in detail during his demo. So I'll skip to the next slide quickly. Yes. Now I want to talk about Couchbase Service Broker and how it works. The reason I want to talk about Couchbase Service Broker is because this is a newly added product in the Couchbase product stack. This is offered under Couchbase Server Enterprise license, similar to that of Couchbase Autonomous Operator, and is available on downloads page under the Cloud Native database, similar to that of CAO. CSB, that is Couchbase Service Broker, is a very efficient tool, and it provides an alternate way to deploy Couchbase cluster on Kubernetes and avail the brokered Kubernetes services. Currently, this has limited capabilities, and we hope to expand this in future. Let's understand how it works. Couchbase Service Broker is a cloud native integration with a CNCF's project known as Open Service Broker API. Couchbase Service Broker provides Couchbase services in the form of managed services that consist of service class and service plans. Once the service broker is registered and published within a Kubernetes service catalog, these managed services are accessible in the Kubernetes marketplace. And then any developer or platform engineer can deploy these managed services through the service plans. They can also integrate their Kubernetes applications or pods to call these managed services through registered endpoints of the service broker. We can achieve many benefits with service broker implementation. Some of them are listed here, such as unified interface that provides customers a single platform to help manage resources through a familiar interface across both on-premises and cloud environments, and which gives a consistent developer experience. Similar to this, Couchbase Service Broker provides easy and efficient cluster deployment. For example, in single command, you can deploy the operator as well as the Couchbase cluster with the help of the registered service plans. Service Broker also provides multi-cloud and hybrid cloud deployments. What you can do is, once the Service Broker is registered with the Kubernetes platform, all the services are available in the Kubernetes marketplace within a domain, and irrespective of whether it's on-prem or whether it's on cloud, you can access, or maybe you know, intercloud or multi-cloud, you can access those plans through any platform as long as it is in the same domain over the Kubernetes clients. Service Broker also provides guided deployment and customizable templates for the customers, where they can specify a particular configuration once and reuse it 100 times, 1,000 times just with one click. You can also upgrade Couchbase, all the Couchbase clusters registered with Service Broker with a single command. Now over to Ron for the demo.
All righty, thank you very much for that great introduction there. And if you could not share your screen, I'll share mine, and we can get started with the demo. So what I'm going to do is I'm going to provide an overview on installing the worker nodes and the monitoring of the pods. I'm going to install Couchbase Autonomous Operator, the pods, Prometheus, Grafana, and also install the service broker. So the whole thing. And what I have here, what you can see here on top is I have an mcluster.shell, and I'm just going to run that. And that's going to actually build my environment. So right now I'm starting up Explorer, and I'm going to show you one other thing here. And you can see that I have the Couchbase Explorer, and you can see that we're building 3 nodes with the kind, which is Kubernetes in Docker. And so I'm building just 3 nodes, and this is a live demo. So it's going to be running for a little bit. And the reason why I put this all in a shell script is so you don't have to watch me type. And so this is going to be, and down here, I have this window is refreshing every 5 seconds. So you'll be able to see the Kubernetes get the pods as the system is built. So you start to see the autonomous operator in there. You'll see the pods that are being developed. And so I'm going to deploy one cluster. And then I'm going to use what Roshani had talked about, is the service broker with one command to deploy a second cluster. Then I'll get on the website and on the web, and I'll interact with the two clusters and do some configurations in that regard. All right, so here we go. And we have our clusters that have been defined, and you can see that we're starting to load the Couchbase Autonomous Operator, the Kubernetes cluster. And I'm also installing the Dynamic Administrator cluster. So if you think about Kind, which is our Kubernetes in Docker, and then CA 2.2, the Docker compute image that I'm loading is going to be Couchbase Server 6.6.2. So Kubernetes will setting up Kubernetes to automate our containers. So like I said, we have 3 worker nodes. Those worker nodes will host the pods on the various pods that I have going on. And as Roshani has said, I'm going to also install Prometheus and Grafana. Now you can see that the operator is installed, and it's now loading Couchbase 662.0, which is the actual, it's part of the cluster. So that's the first device in there. Now I'm going to switch over to my shell script here. And I'm not going to go over all these little commands, but a lot of these are just printf commands. And then I use kubectl to actually install the cluster and create it and that. So right now we finished the DAC, which is the dynamic admission control. I want to say a little bit about that. That allows custom resources to be modified and validated before the requests are accepted, and with webhooks. The operator is really important because that watches your application and performs various customer tasks that on the state of your environment. For example, as you do use auto scaling, you may scale out and you may need to do a rebalance. Well, the autonomous operator knows about that, so it'll automatically rebalance for you. You don't have to go in and manually do that like you would normally. The other thing I want to talk about is Helm. So I'm using Helm to install some of the platforms here. So Helm is a package management deployment system. So we packaged up a Helm, what they call a Helm chart, into our cluster. So this is so that we can easily run a single Helm install, and it makes it really easy to deploy that. For example, here's a Helm upgrade install, and I'm going to install the Couchbase monitor stack. So it's actually a stack, Prometheus and Grafana, and I'll demonstrate that a little bit later. And then what I'm doing is I'm just waiting for that to get done with the sleep. And then I'm going to go on to install the service catalog with Helm as well. So that makes it really nice and easy to deploy the platforms. Now, all this that I'm showing you here can be found on GitHub. So let's look back to our packages here. So you can see that we've got quite a bit going now. We've had our 3 platforms are all up and running. Our service catalog is broker is coming up and running. You can see right here, it's almost ready here. It's actually running. And we have all the Couchbase operators, the service brokers. You can see Grafana and Prometheus are up and running here. So I can start by just starting these up now. Now I'm going to pull in my web browser here, and I'm going to refresh this guy. And if everything's working right, I'll be able to log on to this guy. And again, I'm building everything from scratch, and this is a live demo. So if I look at the number of servers, I have 3 servers here, and that's just what I talked about earlier is my CB662, and that's my the cluster version that I'm using. So when I look at my kind configuration YAML file, I just have 2 nodes and a control plane, and that was evident with the earlier on when I fired that up. That was the first thing that fired up. The next thing I did was I have a data cluster YAML file. Now this is specific for Couchbase. It's a Couchbase example, and I have username and password. And then I go on to create a bucket. Now a bucket in Couchbase is basically a database. So I'm creating this flight aware bucket, and I'm specifying how many megabytes that I want associated with that. And then I come down here to monitoring, and I say, okay, I need to monitor out to the exporter, and I'm going to do that and give it 1 gig of RAM. And this is the actual image that I'm going to install. So it's Couchbase Server 662. I also can do 7.0.1 just by replacing 662. And then I go on to look at the number of servers. So I'm installing 2 servers that are going to be data. And then the third server that I'm going to be installed in the pod, or a container more appropriately, is going to be eventing, analytics, search, and query. And I can differentiate these any way I want. For example, I can have more than 3 servers, and I can put each of these services on each of the containers. Okay, so that's a little bit about that. And then the last one, I'm not going to talk too much about this, but this is just a Grafana JSON file that I'm going to install in the near future here. So let's go back to our Couchbase 662 server, and I'm going to just go to documents. And what I'm going to do is I'm just going to import 10,000 JSON documents, and I have it all in one file. And this is normal for some of our customers. I've done this with one customer. I did it with 75 million different documents. So that's going on its way. Now I want to go back here and just check on my infrastructure, see what's going on. And oh, look at this. So we're seeing that we're starting to build this second cluster here. The second cluster is called Couchbase Instance, and this particular code here, I'm just going to copy that, and I'm going to install that over here and run that. So now I should be able to access that second cluster. So I'm going to come over here, and I'm going to, okay, so I got a login here, and I'm going to just select that guy, and I'm going to put in my password, which is highly secure with password. And now I can see I have this Couchbase instance 0Z8, and I also have three instances here. And right now it's doing a rebalance across those, but you can see that these are another cluster that's set up. The buckets I have a default bucket, and it's still coming up, so that's why you see this is yellow here. But over here, what I want to do is looks like it's going to the importing. Now, what's one of the use cases that I would use this for? So let's say that this Couchbase 662 is our production environment. Now, we have a developer and they want to do some development on this database, but they want to use live data. So what I want to do is I want to transfer over some of this data over to this other Couchbase instance here. So what I'm going to do is I'm going to use XDCR. And this is our data center replication. So what I want to do is I want to add a remote cluster on here. So let's look over here to this guy here, and let's look at the instance here. So I'm going to just do a quick copy of this particular server. I'm going to come back here. I'm going to put that in as the host name. I'm going to put the password in, again, the highly secure password. And then I have to put in the cluster name. So I'm going to come back over here and just get this cluster name, which is just going to be the beginning part of this right here. And copy that. Now, once I put that in, if everything looks good, what it should do is it should connect to that cluster. And it didn't look quite that good. So I forgot the C, which I do that a lot. And there it goes. So it recognized this other cluster. So what I'm going to do is go to that other cluster, the remote cluster, and I'm going to say, okay, here's my server on this particular cluster, and I want you to connect to that. So let's go to XDCR and add a remote. And here's my server, and my cluster name is CB662. I'm going to put in the password. Again, highly secure, and boom, it recognizes it right away. So now they've got the two talking to each other. So now what I can do is I can come back here and I can say XDCR, I want to add a replication. Let's select the bucket, the Flightware bucket. That's where I put the 10,000 documents. And I'm going to pick the cluster I want to go to. This is the only one. I can have lots of them configured if I wanted to for other developers if I wanted to. Now the remote bucket, I'm just going to dump it into the default directory, into the default database or bucket. And then I'm going to save. Now, once I save, what it should do, it should start up and replicating. And if I come over here to my remote cluster, I should start seeing these items start to build. And as you can see, it's starting to build here. So right now I have 6,000 items, and pretty soon here I'm going to have 10,000 items. So basically what I've done is I've given this user, a developer, or I've added another database that has exactly the same documents in it in this other database. And I could use this for an active type partition, or I can use it for anything else that I want to do. Like I was saying, one of the use cases might be for a developer. So let's look and see what we've done here with Prometheus. So with Prometheus here, what I want to do is I want to say, okay, let's look at, so I can see that I have various nodes that are set up here. And anytime you type Couchbase, you know this is working because you're getting all this type of information here. So I can look at cluster memberships and I can see I'm getting some values here, which is great. Now I'm going to come over here to my Grafana, and I'm just going to, so since I just installed this, I have to log in, and it's going to make me change my password. And I'm just going to use this password here, which is just password. I think my password, so good, I'm good to go. The first thing I have to do with Grafana is specify a data source. So here's my data source. And this is all Helm. It installed this nicely for me, so I can test this out. Everything is working just fine. And now what I can do is I can come in here and manage, and I already have a JSON file that I can select called Grafana. Which is right here. This is the one I want to use. And I can open that up and I can import that, and that's automatically going to give me this type of infrastructure. So it's looking at FlightAware, it's looking at all the pods in the default namespace, and it's telling me right now I can click on any of these here. I can go through and I can just about look at any type of information that I want through with Grafana. So it makes it a really easy way to manage and monitor and alert from your various pods. Okay, so this is all running fine. You can see that we have all our infrastructure built up here, and the only thing left that I want to do is I want to show you in my cluster, the one command I used to start my second cluster was just this. So what I did basically is I did an svcat provision CSV, and I use this class. So I'm using Couchbase Autonomous Operator 2.2, and I'm using this particular plan. And these plans you can set up. This is just the basic plan that says, okay, developer, you get three nodes, 3 containers, and it's going to have these services that are built into it. And you can put in the password and things like that. So just by running that one command, I can do that. And that's what I had done in the script. And I can also do a get on the class, so I can see what classes there are. I have 2 classes with Couchbase Autonomous Operator 2.2 as well as 2.1. And then I can also do the plans. And here I have specified 4 different plans that this developer could use or somebody else could use. And these would be Couchbase Autonomous Operator 2.2, and I have a basic and a standard and a basic and a standard for 2.1 as well. And one just has a lot more advanced features than the other. And you can configure these any way you want. It's just a JSON file. So that's it. So everything is up and running. So again, this is a live demo. I created one cluster, and then I created a second cluster, and then I imported data into the cluster. I duplicated the data to this second cluster so that we can have an active or an active passive for failover, if you will, and got everything up and running. So with that, I'm going to pass that back to Roshana, and thank you very much for listening.
Hello again. This is a list of some of the resources. If you want to learn more about how to run Couchbase on Kubernetes, please go to these resources, as well as at the end, there's a GitHub link for Ron's demo, the automated script, and all the files and configuration that he has used for his demo. Please do have a look at it. And once again, thank you so much for attending this session. If you have any questions, please let us know. Thank you.